Hello and welcome to the lecture about hash tables. A hash table is a data structure that stores data items in key value pairs. In a hash table, a new index is generated using keys, and the value corresponding to that key will be stored in that index. This process is called hashing. So it gives you a way of associating a value with its key. We use hash tables to insert, remove, and search data based on their unique key with constant time operation. But why hash tables, and what is the intuition behind that? Suppose we have millions of records and we want to look up a given item. In that case, time complexity will become big O of n. But how about a situation where we know the index? Unlike an array where the average search time is big O of n, but for a hash table, the average search time is big O of 1. Let's jump to an example. Suppose you want to associate fruit's name with some set of information, and in this case, information is calorie, and we have a hash table of size 10. For the hash function, I decided to use division hash function, but it's up to you, and you can use anything as you wish. You can put a key in the hash table, and then you can say, okay, give me the data associated with, for example, watermelon. So first of all, we need to determine the hash value regarding watermelon, and then we can get that information in the hash table that is associated with watermelon. Now the hash table is empty and we want to push the data into our hash table. The hash function takes watermelon and converts it into some sort of integer and then map that integer into an index. Here x is equal to watermelon, but in the following line x is changed to an integer. But how? It's so simple, and we use ASCII code. ASCII code is a character encoding standard in which each letter is associated with a unique code. So all letters of watermelon are associated with a value, then we add them together. The sum is equal to 1086. Go back and extract the remainder. And the output is 6, and 6 indicates to the index of watermelon, and it's calorie. The next one is pineapple. Hash function takes pineapple and the output is equal to 8. Finally, we push pineapple and its calorie into the hash table and do the same process for apple and banana. We put apple at index 0 and banana at index 9. We have a problem here, and let's discuss about that. Hash function takes lemon and the output is equal to 9, but the index 9 is occupied by banana. This is called collision. It's possible that hashing two different strings can probably have the same hash value because we have infinite number of strings but a finite number of hash values. So in this case, both banana and lemon have the same hash value. There are different ways to resolve collision. One method is called chaining, which introduces a linked list. Chaining is possibly the most common solution and is very simple. When there is a collision, just store them in a linked list, and when we want to retrieve data about lemon, then we actually need to look through all the values in that linked list. I hope you enjoyed this lecture, and thanks for watching this video.